All right, so we are going to talk about basic geometrical objects, points, lines, and planes. Before we do that, I'm going to introduce what geometry is about, and then I'm going to describe an issue related to the first definitions. All right, so geometry, let's think about how it exists in relation to other math subjects. So when you studied arithmetic, you were studying quantity, or you might call it the science even. That sounds fancy. The science of quantity. So everything in arithmetic was how do you deal with quantities? If you combine quantities, remove some quantity, how does it affect the leftover quantity? All right. And algebra, there is you can think of it for right now as it's more tricks of arithmetic, right? There was other things that you were doing in algebra in order to handle more complex arithmetic questions. All right, now if you were to continue your discussion of algebra, eventually you would discover that there's more to algebra than just the science of quantity. All right, but we are not going to delve into that right now. So what is left for geometry to study? Well, geometry is the science of space. How do things exist in space, and how do they interact with each other? How do we compare different objects in space? All right. Now, let me give you some of the history of where geometry got started. So way, way back, think of the earliest civilizations. The Egyptians were one of the earliest civilizations. They lived next to a river called the Nile, and the Nile would flood people's farms that were next to the Nile, and so the size of their farm would change depending on how much land was now underwater. All right, and then the Greeks and other civilizations had the same issue. So for various reasons, they needed to they developed methods to measure the size of land, pieces of land. Okay, in fact, the geometry comes from Greek phrase earth measurement. Okay, so geo, it means earth, and metria is the Greek word for measurement. So obviously they were measuring the land, the earth, and so that was how they interpreted. That's what they thought geometry was. Now, of course, today we've expanded it to include much more than just measuring farmland sizes. But anyway, so you get the idea. All right, so let's get back to our discussion of our first geometrical terms. And right away, we bump into an interesting, curious problem. All right, let's say that I wanted, forget about geometry for a minute. Let's say that I wanted to define what a caret was. Okay, so we might start with something like this. A caret is an orange vegetable. All right. Now, however, there's a problem with that. Okay. What if the person was just learning English, and let's say they came from France or Mexico, and they didn't know what orange was? So in order to understand your definition, you have to add another sentence. Well, you have to say, well, okay, orange is that color between yellow and red. Okay, maybe something like that. But then, can you see the problem? Now, you also have to define what a vegetable is. And then, how do we know that they know what yellow and red are, or colors, or between? Okay, so you're going to dig yourself into a bottomless pit, and you're never going to be able to climb back out if you try to define everything. All words in terms of other words in terms of other words. All right, so the only way out of this bottomless pit is we have to pick a few words and define everything else in terms of those few words. Okay, now we are openly going to admit that these few words are not defined. We're not even going to try to define them, because if we even go there, we're going to end up in this trap that we just got into. Okay, so we're going to have undefined terms. These are terms. Well, you can probably picture what they are in your head, but we know that if we try to define them, we would get into this pit. So we're not even going to claim that we can. All right, and these are some terms that we're going to define everything else in terms of are, well, wait for it, points, lines, and planes. Okay, so you can probably picture what these are, and I'm going to use words to describe it, but I'm not going to claim that. Well, I'm just going to try my best, and we'll see how it goes. But you know why you know what issues going on. Okay, so a point. Points have to do with positions in space. All right, points, positions. Now, notice I didn't say it equals positions, because that would be a definition. But it's kind of when you think of it, think about positions in space. Yes, I know I'm kind of being weaselly, but again, now you see why. So, like if I had a number line, and I realize I haven't defined what a line is yet. So, but you could label all the points along a line, if you remember from your algebra class. Okay, and so each of those points, like this green dot, I'm putting a dot there to represent the point located that I've marked 1. That is a position. All right, so that's, you can think about that when you think of points. All right, now lines. Let's talk about lines now. Excuse me, let me get ready. Okay, lines are composed of multiple points. All right, notice I didn't say how they're composed, how many points. Okay, I didn't go there. But when you think of a line, think of you scrunch a bunch of points together in some way, and that's what a line is. And I've already drawn one. Okay, so if you think about a bunch of points, which you might imagine dots, if you put a bunch of those dots together, like I'll do here at the bottom of the whiteboard, all right, if I could really scrunch a million billion, and I keep going without stopping, they would all these dots would bunch together, and you would get something that is probably what you think of when you think of a line. All right. Now, that is an example of a straight line. We also have curved lines that are not all in the same direction. Okay. And the last one, a plane. All right, let's briefly say something about planes. So planes, and I'm going to give a weaselly sentence here again. Planes are composed of multiple lines. Okay, so if you think about scrunching a bunch of lines together, I'll do these in blue. Okay, and if you got them closer and closer together, a million, a billion, right? And you kept going, eventually you would see that what you would get was it would basically cover, you'd have a surface, a sheet of paper. Okay, now the line, when we think of the line, to keep things simple, we imagine that it's infinitely long. There's no finite length to it. Likewise with the plane, we imagine it like a surface infinitely, or sheet infinitely long in every direction. Okay? Points, lines, and planes. And I also introduced the idea of straight lines and curved lines. let me now finish by talking about the notation for points and lines, and then what it means for points to be collinear or linear. All right. So if we're talking about points, we usually represent those by letters. All right. So for example, points, you can like point A, point B, point C. Okay. Now lines, I already said, are composed of multiple points. All right. So what you can do to represent a line is take any 2 points on the line, and those will unambiguously tell you what line you're talking about. So for example, the points A and B, okay, we'll put a little bar on top. That represents the line that goes through those 2 points. Or B and C, all right, or X and Y. So 2 capital letters with a bar above. All right, that's the standard notation. Now, if you forget the bar, so if you just write A and B, that is a length. The length, the distance between those 2 points, that's something different. All right, which we'll talk about later. All right, and then finally, for to say that points are collinear or not, let's talk about that. So collinear points. Collinear points, all lie along the same straight line. And by the way, I realize that when I say line, it may not be clear. Am I talking about a straight line or a curved line? If I don't specify which one, please assume that I'm implying a straight line. Okay, so for this definition, I could have just removed the word straight, and hopefully that would have still been clear. Okay, non-collinear points do not all lie along the same straight line, or just the same line. Okay, so for example, collinear. So an example of collinear points would be like dot, dot, dot. Those 3 are all along this guy, okay? And then non-collinear would be, let's say the dots were now like this. All right, I dare you to draw a line between a straight line that goes through those 3 dots. All right, you're not going to be able to do it. There's just no way. You can go through 2, but not all 3 at the same time.